And so here, this is a chapter on forces. So I'm not going to write these terms down. I'm going to let you write them down yourself, but make sure that you recognize what variables correspond to which unit. So I highly recommend that you keep this as like a little sheet of paper next to you. And that's because that's going to help you decide what a variable is given when you solve the word problems. So these are the terms that we'll be looking at. And these are the equations that we'll be looking at here. So if you want, you can try to write these down really quickly so that you'll know, to what to focus on when it comes up during the lecture again. So I'll give you a minute to write that down. So if you have a boat here and the boat has a sail, and let's say that the wind is blowing on the sail, so the wind is going to exert a force on that sail. And the boat is going to have a mass M. So as time goes by, the boat starts stationary, but as the wind keeps on blowing, the boat is going to start, it's not moving, and then it moves a little, and then it's going to move a little bit more, and then it's going to speed up. But that means that the boat is going to accelerate. And this is Newton's second law. And Newton's second law says that a force that acts on an object with a mass M is going to give it an acceleration A. But we have to be clear here is you have to take the total force to get the right answer. So Newton's second law says that the total force acting on an object is going to equal the mass of the object times its acceleration. Everybody follow that? Okay. So force is going to have units of newtons, or a capital N. So all forces are going to have units of newtons. So we saw this video last class, so I'm not going to play the sound, but we just have to look at, this is going to be a clear example. So here, you drop the ball, and each second you're going to see how far the ball falls. So you see there, after a few seconds, the ball falls a small distance first, and then more time goes by, it falls over a longer distance. I guess I'll just pick it up from there. 4 seconds to travel this even longer distance here, 2 square tick marks. So keep on letting it fall. So you can see there, between, let's say after 1 second, between 3 and 4 seconds, it moves 2 squares. And then after another second interval, but this time between 7 and 8 seconds, it travels 4 squares. So after each second, it travels a longer distance, which means that it must be accelerating. And that's it. So all objects, when they fall, they accelerate. So there has to be a force acting on an object to make it speed up as it falls. So this is this section here. So if this is the ground, any object that's in midair, when you drop it, it's going to start off stationary, and then it's going to speed up as it falls. And what that means then is that it's going to accelerate. Remember, we got that last class. All objects, when they fall, their acceleration is equal to negative g. So now, by Newton's second law, there has to be a force acting on that object. And that force, this is due to the Earth's gravity. So we're going to call this the gravitational force Fg. So we're going to say that the gravitational force is going to be the mass of the object times its acceleration, which is going to be g. And another name for gravitational force is weight. So both of those mean the same thing. Everybody follow that? Okay. And your weight always points downward. So let's say if this is the ground here, and you're standing on the ground, your weight is always going to point towards the center of the Earth. Everybody, can you hear me? Okay, so let's go ahead and begin with the review. Here's our first question. Convert what is the mass of a 2,000-pound elephant? So what you need to do first is convert pounds to newtons, and then try to get the mass of that elephant. So I'll give you 5 minutes won't be enough, so I'll give you 10 minutes for this one. Okay, ready for this one? All right. So you're given a weight, 2,000 pounds. And you're trying to find the mass. But you have to convert the weight first to newtons. So you have 2,000 pounds, and you want to convert that to newtons, so put a bar. Pounds is on top here, so put pounds on the bottom, and then cancel. And we're going from pounds to newtons. And over here, this tells you that the 1 pound is 4.45 newtons. So then 1 is going to go here, and 4.45 is going to go there. And so in terms of the weight now in newtons is going to be 8,900 newtons. Everybody follow that? Okay. So now we're good because the weight is equal to mass times g. So in order to use this formula, the force always has to be in newtons, and we got that in newtons. All right, so now we can solve for the mass. So all we have to do is divide this side by g, and then divide that side by g. So then the mass is going to be the weight divided by g, or 8,900 divided by 9.81. And that's going to come out to be 907.2 kilograms. G is 9.81. If you already see a G, that means 9.81. Mass is always in kilograms. That's the basic unit for mass. Whenever you use Newton's equations, the mass always has to be in kilograms, and the weight has to be in newtons. Those are the standard units. Does that answer your question? Okay. All right, so let's go on to the next one.